In this video, we will discuss about residual crack stress and quench cracks. So far discussed about various key treatment processes and this TTT diagram. Okay, let us draw that once more. Here, that is the utility temperature. You have the seeker like this. The two seekers are this one. And you know that when cooling occurs, sudden cooling, it will lead to the formation of martensite. Is martensite formation start here, martensite formation finishes. So you can see that when this transformation occurs, that means this austenite, austenite, that is gamma to this martensite. What happens to the density? You know that we have discussed that martensite has got a body-centered tetragonal structure, and this austenite has got a face-centered cubic structure. So that means tetragonal means the one edge of the length is one edge of the cube is greater than the other edge. So that means this volume of this austenite, the volume of the martensite is greater than the volume of the austenite. Okay. That means volume increases during the transformation. Volume increases during transformation. Volume increases during transformation. Okay. So, so during this transformation process, if you take the gamma here, so you know that the cooling first takes place on the surface. Okay. So this surface, so this first the surface will get converted to martensite. Okay. The surface of this austenite is getting converted to martensite. So this gamma will get converted to martensite after a period of time. First, the surface will converted to martensite. But the problem is that this martensite, volume of this martensite is greater than the volume of austenite. Okay. So that means when this inner part of austenite uh, gets transformed to martensite, the associated volume expansion. So it would try to expand. That means try to expand. Expansion is resisted by already transformed martensite. Already transformed martensite on the surface. On surface. Okay. So see, this causes a residual stress. This causes a residual stress. That means this causes a compression stress on the inside because that expansion is restricted by the outside layer. So the inside layer gets compressed and you have a tensile stress, okay, on outside. The tensile stress goes outside. Sorry, tensile stress right on the outside, or you can it as surface. Okay, so this tensile stress on surface martensite. So on the surface you have martensite lead to crack called Quench cracks. Called Quench cracks. These are called Quench cracks. So how to solve this problem? So how to avoid this So just I will show that how the residual stress forms in this curve. You can see that. See, see, this shows. See, this transformation shows here is the surface. Okay, so that means I told you the inner layer flows coolly. So this will be the time. Okay, it will take a longer time. This inner surface will take a longer time. Okay, so what can I do? So this can be solved by a process called mark quenching, or this can be called mark tempering, mark tempering. So in this process, what we are trying to do is, so here, what we do here is we are quenching it, and just above this martensite formation temperature, we are holding for a period of time and then cooling it. See, by holding it for this period of time, all the inside and the surface, all of these will get time to get converted to martensite. So, and the final martensite forms after this particular period of time. So, this is called mark quenching or mark. That means we are quenching it and to a particular temperature, to a particular temperature above the martensite formation starts, above martensite starts, and holding it for a period of time, holding it for a period of time, and then cooling, cooling it. By holding it for a period of time, see, we will allow sufficient time for uh, the surface and inner martensite to transport. So this is called mark quenching or mark tempering.